Imagine you're on a game show. In front of you are 3 doors. Behind one of them is a brand new car. Behind the other 2, goats. You pick door number 1. The host, who knows what's behind every door, opens door number 3, revealing a goat. Now he asks you, do you want to switch to door number 2? Most people say it doesn't matter. But it absolutely does. Here's why your gut gets it wrong. After the host opens a door, you see 2 closed doors and think, well, it's 50-50 now. But that reasoning ignores something crucial. The host didn't open a random door. He specifically chose a losing door. That choice carries information. Let's see why. Let's map out every possibility. When you first pick, there's a 1 in 3 chance the car is behind your door, and a 2 in 3 chance it's behind one of the others. Now watch carefully. If the car is behind your door, switching loses. That happens 1/3 of the time. But if the car is behind either other door, the host is forced to reveal the only remaining goat, and switching wins. That happens 2/3 of the time. Switching doubles your odds. Still not convinced? Let's push it to the extreme. Imagine 100 doors. You pick one. The host, who knows everything, opens 98 losing doors, leaving just yours and one other. Would you switch now? Of course you would. Your original pick had a 1 in 100 chance. That other door is holding all the remaining probability. 99 out of 100. The beautiful lesson here is that information changes probability. The host's deliberate choice funnels the 2/3 probability into that single remaining door. Always switch. Thanks for watching. If this blew your mind, subscribe for more math teasers.